Okay. This was another example. Let me do one. Actually, well, in the next example, there's like 2 in there. So I guess technically we have 2 more examples. Then what I'll do is I'll start chapter 10. All right. So here we have a deck of 52 cards, right? You know, and again, we're getting 5 cards. I mean, I wrote down we're playing poker, but the idea is we're getting 5 cards at a time that we're being dealt that without replacement. And the order doesn't matter either. Okay? The order doesn't matter. So now we want the probability that all 5 cards are hearts. All 5 of them are hearts. Actually, not that bad. Let me just do this, though. Actually, not that bad. Remember, each suit, right? There are 4 suits. Hearts is one of them. And, oh, sorry, wrong button. Jeez. Each suit has 13 cards. Okay? We want 5 from the suit of hearts. We don't care about order. Repetition's not allowed. That's what the C of 13-5 is. Because of that, right? Because of that, the probability of getting all 5 cards being hearts would be this. Right? The top is the number of favorable outcomes. The bottom is all possible outcomes. So we get this thing. So we get this here. Okay, that's cool. That was fun. Okay, what about this? What if now we want the probability that only 4 of the cards are hearts? So we only want 4 of the cards being hearts. Okay. Well, again, the order doesn't matter. So let's just say that the first 4 are all hearts. We want that to occur, right? How is that going to happen? Well, that's what this is. The 13 cards from the suit of hearts, right? But you want 4 from that. And, you know, no repetition. We don't care about order. That's what the C of 13-4 is. And you could probably tell from what I wrote that, you know, we are not done because we have to worry about the last card. That card we have to worry about. Okay, now this card here cannot be a heart, right? How many cards are not hearts? Well, 39. Right? If there are 13 cards that are hearts, right? And there's 52 cards altogether, and there's 39 cards that are not hearts. Or if you want, you can think of it this way. The other suits, you know, spades, diamonds, hearts, spades, diamonds, and clubs, right? Each of those is a suit. Each have 13 cards in them. So there's 39 remaining possibilities for the last card. So for the first 4, we have that C of 13-4. We have 39 possibilities for the last one. So by the basic counting rule, we just multiply. Down here. Okay. So by the basic counting rule, fix this. By the basic counting rule, as you can see, we have C of 13-4 times 39 possibilities. Again, there are 39 possibilities for the last card. So the probability then would be this quotient. And this is what we get. Okay, that's actually it for chapter 9. what I'm going to do now is normally I would like to give a worksheet, but unfortunately I didn't get a chance to go through one. So I figured the best thing would be now to start statistics, which is chapter 10. So let me do that. Hold on, let me share it. Okay. Okay, so now we're in chapter 10. Okay. I'm hoping to do 10, 11, and 12 before the semester ends, but we'll see. So basically here, in this chapter, in chapter 10 that is, we're looking at statistics, kind of getting an introduction to it. What happens in statistics is basically you get to gather information, like data, so to say, from groups of people, analyzing the data, making predictions, as you can see. And you also have to present the data. You can present it through things like histograms, scatter plots, different kinds of charts, different kinds of visual, so to say. Now, it turns out also that probability and statistics are related. I'm not sure how much we'll see both at the same time, but we'll see. So in statistics, as I just said a minute ago, we analyze groups of people and we like to make predictions about them. Usually, from data and stuff. So in particular, there will be some vocabulary, just like any, I guess, new science. There will be vocabulary. We'll see things like what populations are and samples. Essentially, you'll see that populations, that's the big group of people, or really whatever objects you're studying. Off the top of my head, I can't think of what else besides people you can study. I guess you could study animals, but people, for instance, you can study like a group of people, like all New Yorkers or all SUNY Oneonta college students, that kind of thing. You could wonder, how do SUNY Oneonta college students, how do they feel about Trump? Or how do they feel about our governor? That kind of thing. Generally, what will happen is it's going to be too complicated and too expensive and time consuming to get data from every single member of the population. The populations are not going to be just like 10 or 20 people. It's going to be like thousands or maybe even a lot more. So what people do is they look at what are called samples. A sample is a sub-collection of the population. And that's where sampling methods come into play because you have to be careful with the kind of sample you form. And what can happen with sampling methods, what you want to happen is you want your sample to be representative of the entire population. That's what you want. So there are things that can go wrong, though. Like you can have a sample that's not representative of the population. And there's different kinds of things like experiments you can do. And then there are things called observational studies. We'll get to that. And then, of course, like I said, you have to present the data and conclusions. We'll get to that as well. All right. Like I said before, we do consider groups of, objects or people at one time. And this is just an example I just came up with, basically. The population is the group where you're getting data from. The group that you're studying, in other words, the group of objects or people of interest in a study. So like, for instance, if we wanted to know how many hours of reading per week a typical college student does at SUNY Oneonta, let's say, our population could be SUNY Oneonta students. That's just one example. What has to happen though is you must specify your population. You have to be specific. Mostly because if you change the population, the results could change actually. I mean, think about it. If you were to ask, let's say, how do I say it? Oh, it's like what I have over here actually. If you were only to ask college students that are majoring in philosophy or like another humanities field like history, their answers are going to be very different. And if you were to only ask physics majors or math majors, I'm not too sure how much reading each major actually does. It's been a long time since I took those kind of courses, but I'm pretty sure that the humanities field, like philosophy and history, have a lot more reading than like physics or math. I could be wrong about that though. And again, you don't want to just say something like, "Oh, just college students." You want to be specific. If you compare SUNY Oneonta students to, I don't know, to students that go to Stanford or Harvard or whatever, the answers could be very different. So you have to be specific about your population. That's really what I'm saying here. There we go. And this is just some more vocabulary. Basically, what you're going to do is look at parameters. Parameter is just a value that calculate using the data from a population. So in that example that we just said with the reading, how much reading each person does per week, that would be a parameter. Mostly because, again, you're getting data from the population. I mean, you could use a census. That's a survey of the entire population. But again, like I said before, you don't want to necessarily have to deal with the entire population at once. That would be, very tedious. I'm not sure how many SUNY Oneonta students, though. I want to say there's got to be a couple thousand, I would think. That's why we like to look at samples. With a sample, you're looking at a subset of the population. And again, you want to make sure you choose one that's fairly representative. You don't want to just choose, for instance, students that major in history. Or you don't want to choose, for instance, just juniors, at SUNY Oneonta. That can really hurt the results. And then I have the definition of statistics. That's just a value you calculate from the sample. So we probably should. I mean, there's stuff here, but we probably should stop here because we have like a minute left. And this is pretty much what I said anyway. You want to be careful when you're forming a sample. You have to use like certain techniques. So you basically want to make sure your sample is really representative of the population. All right, so probably we should stop here.